everyone. For today, we want to discuss how to move forward with the pod level checkpoint restore cap. I'll try to share my screen.
Oh, it looks like whoever is logged in as the host probably needs to.
Yeah, that's me. That's me. Yeah.
Oh, okay. Also realize I logged in as Kubernetes Network instead of my personal account.
Yeah.
Ignore that.
I'm just trying to find the right tab to share. Yeah, this one. Okay, cool. Yeah, so essentially for the pod level checkpoint restore cap, we're currently investigating what is the best way to implement this functionality. And Adrian created like a simple proof of concept where we implement something similar to what we had for container checkpoints. So essentially the way it works is we have an API endpoint where we have essentially pod checkpoint API where we can specify the name of the pod that we want to checkpoint and additional checkpoint options. So this is kind of similar to the existing API. And essentially for the cap itself, we need to assign the approvers and complete tick all the checkboxes that we need. But one thing that I want to ask Andre was whether I'll try to share the other tab. Essentially, in the Google Kubernetes engine, we have something called trigger checkpoint, and there are essentially two ways of doing that. One is essentially creating a checkpoint by manually creating the checkpoint using the API, for example. And the other one is by essentially the application itself creating the checkpoint from inside of the, essentially from the container itself. I will try to. Yeah, I think this should work. So essentially, it's this snapshot policy. So essentially, this trigger type is the method that I was referring to. And I want to ask Andre if he has any idea of how this could be implemented in essentially in container runtimes. I know that gvisor provides essentially this proc gvisor checkpoint, but essentially we probably don't want to implement this at kernel level. I was wondering if there is some communication mechanism like something that we can use in runc or crun, or like I just want to ask Andre if he has any ideas on how we could potentially implement this. But I guess the main reason this is useful is, for example, when you have training workloads that, for example, you want to create a checkpoint at the end of an epoch, and you want the application to essentially trigger the checkpoint itself rather than creating a checkpoint in the middle. Andre, I'm not sure if I cannot hear you if you're.
Oh, do you hear me now?
Yes.
Okay. Yeah, I understand what you mean. And if you're talking, for example, about gvisor, in gvisor they just introduce a proc gvisor checkpoint file for that. We can't do the same in Linux, but for native containers, we can create FIFO or Unix socket and runtime can handle events from this socket. I don't know. I mean, in this case, runtime is probably will be containerd because we are talking about the pod level checkpoint restore. So it's not runc. Runc, it's about no. Do we track pods in runc?
No. So essentially, we create the containers in runc. So I guess we have to know this.
I think runc handles just containers, and pod abstraction will be visible only on the containerd level. So if we want to have this functionality, we probably will need to implement it in containerd, and inside container it will be just like Unix file socket, or it will be FIFO. I think like both will work. Usually I like sockets more because they are more functional, will give you more, it's more flexible. And we will need to handle this in CRIU because we will see these external sockets and we will need to handle this external socket properly. But all this is doable.
Okay. My understanding is the way this works is with gvisor is essentially we have this one. Essentially, we write just the number one to trigger the checkpointing mechanism. And this will create the actual checkpoint. There is also an example here. But I was discussing this with Adrian earlier, and he said we have to also consider security, like essentially preventing the application from creating denial of service by creating a lot of checkpoints. But I guess this is something that the container runtime, for example, containerd has to handle.
Yes, I think so.
And I want to ask Vicky. I was looking at how the Google Kubernetes engine configures the snapshot mechanism, and it looks like the best way of doing that is essentially using these snapshot policies. So essentially the way this works is you have these match labels. So for example, if you have different pods running in Kubernetes, what you can do here is you can use different type of configuration for essentially the workload, for different workloads. And I think this is probably a better way of doing it. What we currently do is we have an API endpoint, and every time when you want to create a checkpoint, you have to specify the configurations that you want. But this seems to be like a better approach in a way that you set all the configurations that you want once, and then every time when you create a checkpoint, it automatically picks up. What do you think?
I don't know. I didn't have time to check the policy. Can you maybe tell me what can you configure it?
Yeah, I think this is so we have these two types of essentially trigger mechanism. So what you can configure here is whether the checkpoint is essentially triggered from inside of the workload, or essentially it's triggered manually, or you can also, I think, specify the storage. So I think gvisor, there is only one type of storage at the moment, but this was something that can be configured. I think the main idea is that this is something extensible. So in the future, you can add additional configurations.
Yeah, I don't know at the moment what to think about this policy. It looks like something that would want to mimic like a priority class, that you set something and you can then reuse it. But at the same time, I see that there is like post checkpoint resume. Maybe there could also be, like we've stopped, so do not resume. But I thought that we want to mimic this behavior more with like extra API commands, like that you would do migrate or that you would do resume, extra, that you don't need policy for that?
Yeah, essentially, the problem with using essentially specifying the checkpoint options, like for example, leave running as part of the API endpoint, is that you have to do it all the time. Like every time when you want to create a checkpoint, you have to specify the options that you want. Whereas with this, essentially with this custom resource definition, you're configuring the checkpoint options only once, and then every time when you create a checkpoint, it happens. Essentially, they're picked up. But I think Felipe, he also mentioned that he was experimenting with this last time, and I was wondering if you have any comments.
So I don't have anything special. Like I spend like a considerable amount of time trying to understand how this works. The thing that I is really good about this solution is that it's clear on the high level Kubernetes what you're doing because you configure it in advance, so it's not a cowboy word. It's actually like something that is you say what and to where, and it's very easy to do it. One thing that I did not fully understand, and I think that's what we have to ponder about a lot, is the requests that were made by multiple engineers of other teams, is how these things would work together with scheduling. I think it's very important, for example, like to not forget queue. That's is being very popular. I don't know how Google is using this snapshot with queue, if they are even using it at this point. There was also like the presentation about pod eviction, and this could also be considered for pod eviction snapshot and do something else with the pod instead of killing it like immediately. I shared with you just to have an idea because I think we focused a lot on low level and we forgot about how we would make things work with scheduling. And maybe this would give us idea to what we need to actually like store on Kubernetes, right? We need to think about that also for the next steps of KEP or whatever we propose.
Yes, actually, Victoria was working on this. Vicky, she wrote a user story about the eviction use case.
So, what do you mean by how would it work with scheduling? Because just with preemption itself, let's say you could set whether you want the workloads to be preempted via deletion or delete call, or if you want the workload to be checkpointed instead of deletion. But then the scheduling itself, like, are you suggesting some changes in the scheduler that, for example, resumed workloads are treated differently, or they have like different priority, or they have different way of entering the queue, or what? I
Yeah.
went to one SIG scheduling meeting some time ago when we were just setting up the working group, and there we discussed this briefly. They said that scheduling is, some later part of this, because all this like lower level stuff needs to be first done in order to be somehow put into scheduling. We need all APIs and everything. That's one thing. And the second thing is that SIG scheduling is also now working, at least I see that way, that they are working on like workload aware preemption and workload aware scheduling, and that is some sort of advancement in the scheduling strategies. So I think that we will like need to define what we want to start with the introduction of checkpoint and restore, and what it should do with the scheduling.
Yeah. My point was not like to get that deep. Is more that the CRD or whatever we create, right, is a contract for whoever is going to use it. What I meant is that we have to think about that as something that the schedule can also use to make decisions, right? Not necessarily like thinking only about schedule, but there should be something universal, I would say.
Yeah, if you just pure scheduling doesn't really care about custom resources, it cares about pods and the workloads themselves. So of course, like the snapshot policy, the pod snapshot policy, our version of it could maybe influence something about scheduling. There could be some information. Though I don't know at the moment like what type, but there could be something and the schedule could work with it. And I see the SIG network hand.
Sorry, I logged into the wrong account. This is Bowie from SIG Network. I'm curious, I'm looking through the proposed KEP. Like, do we have a good notion of what the life cycle of these resources are? I apologize, I'm sort of new, first time in this meeting. And like, do we even know if, for example, when you restore, like what's the relationship between the various things? Like, do you restore targeting a snapshot, or is it simply a pod that's configured to reference an existing snapshot? Do we have I'm just curious. Please forward me to a doc if this is all kind of well defined.
So in terms of lifecycle, do you mean the lifecycle of the snapshots or the lifecycle of the pod?
Yeah, so for example, checkpoint restore, you have a checkpoint which goes to a snapshot, and then you could either have like a one-to-one relationship with the snapshot, or you could have like a one-to-many where the snapshot is used to sort of actually just like it's like running from a snapshot. Like which one are we kind of thinking about?
Yes,
or maybe
so,
both.
there are different types of use cases, and essentially we're trying to create something generic. So, for example, one of the use cases that is quite important is when you want to accelerate the startup time of inference or workloads. Like, for example, you have VO1 and it takes like a minute or 2 minutes to initialize the GPU state. And then if you create a snapshot after this state is initialized, then you can resume from this snapshot very quickly. So this is essentially one of the use cases where we can essentially create a snapshot so that we can accelerate the checkpoints. In this case, we can also use this to scale functions. So for example, if you want to replicate a pod, the snapshot mechanism allows you to do that. The other use cases we were discussing in the Kubeflow meeting was when you have training workloads, then essentially you may want to preempt to essentially stop the training job. And in this case, you have like one-to-one relation where essentially you have a single checkpoint that is used to resume the workload. And then we have another use case where you want to migrate. Essentially, we want to move a pod from one node to another. And then we use, again, the snapshot as the checkpoint itself to essentially save the state of the pod and then to resume it later. So we're trying to create something that would work with different use cases. Did that answer your question?
Yeah, are those CUJs like user journeys like captured somewhere? I see there's user stories right here.
Yeah, we actually have another KEP that was Adrian wrote, I think, a year ago, and it has more details on user stories. But yeah, we can expand this as well.
I think the relationship of that and, for example, the CR would be useful, I think, to make it very explicit. I heard some talk about scheduling, right? It's like, is it the case that scheduling is more of like a pod issue? And for example, this in the startup latency user journey, a pod says, I may have a thing that's cached that will help me start up faster, but it's really, the scheduling is almost entirely on the pod side versus related to checkpointing. Does that make sense? Whereas if you had the one-to-one relationship, there needs to be involvement with the kind of like the whole workload lifecycle to ensure that you only have one copy running at a given time.
Yeah, I think the main use case for scheduling is when pods are being preempted. You know, like when the scheduler preempts a pod, it will just terminate the pod, and instead of terminating it, it will create a checkpoint, and then essentially use this checkpoint to resume. I think this is pretty much the most useful. Like, for example, if you have something that runs for several hours and it's being preempted, you probably want to essentially create a checkpoint and then resume from this checkpoint. Is that what you meant, or?
I guess like how, again, I could take this offline, but like, what is, are we proposing to add an API to like deployment? I'm trying to understand in terms of all the different workload, like orchestration mechanisms, like where the user kind of interacts with it to say like, you're being preempted and then reschedule me. Like, what does that look like?
We have been discussing in relation to all these use cases how to model the checkpoint itself. What does it mean? If it's a property of a pod, like a new set of fields or new section, or if it's a new custom resource definition, similarly as we see with Google Kubernetes Engine, or as you now mentioned, deployments. One while we have been debating whether it's something similar to revisions, that we could model it as revisions, or if we could model it as jobs that have suspend. There is the suspend field. I don't think we came to one specific conclusion here, but we came to the conclusion that the intended usage of the object depends on the use case, because you might want to reuse the checkpoint maybe multiple times if you are restarting like replicas of a deployment, or you might want to store it for later. Maybe you don't want to restart right away. Maybe you will restart later. And it might serve then as a new object. I think that you once mentioned something about IDs or UIDs, and we have been debating that too, whether restored pod is the same pod. Does it therefore get new? Does it get the same UID? It's also useful for monitoring tools because like Prometheus, let's say, exports pod UID, and you might want to do some statistics, and this is the same workload for you. Or does it get new UID because the new restored workload? No, because the restored workload is just new one. And I don't think that we came to like a very specific decision here, what needs to be done, and that we are still looking for the whole model of it. Also with the life cycle, we think that maybe it would be good to introduce some sort of new status to the pod field to suggest that the pod is like in a checkpointed state or in a resumed state, but maybe resumed is not needed. Maybe we could just like switch checkpointed to running again. So maybe you have some thought on that from like your perspective in the SIGNet, that you might see some resemblance to some other objects.
I think one thing that would be good is to see how, for example, pod UID, if we're talking about like a Kubernetes resource UID, I don't know if there's like a huge amount of flexibility in terms of recycling that, right, for a resource. So like, I think like, yes, if you had to clean sheet redesign everything, then like some of these things are possible, but it would be good to identify like which ones will be easily changeable, right? I'll give you another example, like you're talking about the pod, like the status and kind of the conditions. Like there are a lot of other components in the ecosystem that kind of rely on the semantics of those. So if you introduce a new one, or like really change the semantics of kind of how it works, the rest of the ecosystem also has to kind of sign off on that. And so like what I'm saying is like, make sure for each of these like changes to the system, like it's like there is this sort of like, how possible is it? How many ecosystem partners you need to interact with to kind of like make a change, and then kind of what is feasible. Because yeah, like changing some of the more fundamental things, and this is just talk about SIG Network. My experience with SIG Network is like there are some resources, and pod is obviously like very central one. For example, service, that's like almost impossible to change some stuff about it. So this is just like very high level observation of like whatever proposal you're kind of pursuing here, just make sure like the things that you're targeting are feasible.
Yes, we discussed this last time. We want essentially to reduce the scope and want to focus on essentially kubelet level checkpoints. So once we are able to save and restore complete pod checkpoint, then we can look into how we can integrate this with the scheduler and essentially other things on top of that. But yeah, this is what we were discussing last time. And I think, Philippe, you also raised your hand at some point.
No, nothing to add. Like I want to add like I think the main challenge, at least like as I told you guys, have been doing that. Like we also have customers in production. Like fighting replica controllers is the most difficult thing of doing migrations. This is the hardest thing ever. Network is on top. Network migration is on top, and you have like replica controllers. Because you have a lot of problems, like as you mentioned, regarding IDs or uniqueness in Kubernetes. For example, I'll give the example of stateful sets. Stateful sets, they cannot exist in the cluster. They should have the same name, and you cannot duplicate the resource. So it's kind of a very hard problem as well, and has to be taken. We have to take it in consideration when design the solution. But I think we are far away, and we should focus on the kube CTL, CTL checkpoint and restore. Yeah, it's like small is better for us, right?
Yeah. I just want to check, because there are a lot of people on the meeting. I just want to check if anyone else has any questions or comments. Yes.
Hey, this is Haiyan from Google. I also have a question. You mentioned the kubelet checkpoint API. It's already in beta currently. Is the plan to extend the kubelet checkpoint API so it can, serve the purpose of this user journey better, or is something else?
Yes. So what we currently have in beta version is a container level checkpoint. So this API allows you to checkpoint individual containers inside a pod. And we're now working on essentially introducing a new API that allows you to checkpoint individual pods. So this will contain it will checkpoint all containers inside of pods.
Oh, so we go above a level, right?
Yeah, because in Kubernetes we usually deal with pods rather than containers, and essentially we decided that it would be better to have a separate API for pods.
I see. Thank you for the clarification.
And I just want to check if there are any other questions or. Okay, I mean, I will follow up with Peter and Adrian to kind of decide what to do with how to move forward with the KEP for pod level checkpoints. And yeah, for next meeting, I'll try to essentially update the Capital.js comments. And yeah, I think this is pretty much everything for today. Thank you, everyone.
You.
Okay.